Recently, Andrej Karpathy, formerly of Tesla, Ashok Elluswamy, head of Tesla's AI, and even Elon Musk, who of course is the techno king of Tesla, had something to say about reinforcement learning through reality rather than through human feedback. And while I posted some thoughts on X, I thought it was definitely worth a video, so let's take a look. Hey y'all, it's Dr. Know-It-All. I'm going to start with Ashok Elluswamy's response to Andrej Karpathy's post. Then, of course, we will read Andrej's post. He said, "It's game over when we actually figure it out." And that was actually the first thing I came across, and I was like, oh, I wonder what he is talking about. So then, of course, I had to look at Andrej's original post up here, which says that reinforcement learning is just barely reinforcement learning. So let's read over Andrej's post here. RLHF is barely reinforcement learning. Reinforcement learning from human feedback, or RLHF, is the third and last major stage of training a large language model after pre-training and supervised fine-tuning, or SFT. My rant on RLHF is that it is just barely reinforcement learning in a way that I think is not too widely appreciated. RL is powerful, RLHF is not. Let's take a look at the example of AlphaGo. AlphaGo was trained with actual reinforcement learning. The computer played games of Go and trained on rollouts that maximized the reward function, winning the game, eventually surpassing the best human players at Go. AlphaGo was not trained with RLHF. If it were, it would not have worked nearly as well. And of course, Andrej did not discover this example. This has been widespread in the literature. The original version of AlphaGo, which I think was actually called AlphaGo, and I think the other one was named AlphaZero. I can't remember the ordering of the names. But anyway, the one that beat Lee Sedol in the very, very famous Go tournament back in, I think, 2015 or 2016, was in fact trained primarily on human games that it studied. But the next version, which I think was called AlphaZero, although again, it might have it backwards. But anyway, what Andrej is referring to as AlphaGo here was not trained on human examples. The neural networks were just given the rules of the game and allowed to play each other. There were two adversarial ones that were consistently training against each other, right, to get better and better. But they were given the rules of the game and they just played millions upon millions of games. And very rapidly, they outstripped the best human players. So while the original version was as good as the best human players, the new version that just used reinforcement learning without human in the loop feedback was and is substantially better than the best human Go players. So Andrej continues by talking about this. And by the way, the two board states, Andrej later admits this is just an example. These are not actually two similar boards or whatever. So anyway, some people called him out on that and he was like, look, I just found some pictures and put them on. But basically here you give a human being two versions of a state of a board, right? So on the left might be one board where white is slightly dominant. On the left is another board where black is slightly dominant. And I can't play Go well enough to tell you what that might look like. But anyway, you give a human two similar board states and you ask them in which one the white player is doing better than the black player or something, and they vote. And so humans can do that, right? They can fairly quickly say yes or no, which board state is better. But with a complicated game like Go, even with the best players in the world, it's going to take, let's say, 30 seconds or a minute per board examination to try to figure out which one looks better. So immediately you can see where the problem is. The human being is taking like 30 seconds, whereas a system that's trained to play itself can play hundreds or thousands of games per second if it's split across many, many GPUs. So that's orders and orders of magnitude faster than just giving human board states, and you get complete games by that. So you get the entire game played and then the reinforcement step of did you win or did you lose, and you can then back propagate that. So it's much, much faster to do reinforcement learning without humans in the loop, or reinforcement learning rather than RLHF. So as Andrej says, you'd give human labelers two board states from Go and ask them which one they like better. Then you collect, say, 100,000 comparisons like this, and you'd train a reward model, or RM, neural network, which is a whole separate neural network, to imitate this human, quote, vibe check of the board state. And I like vibe check. It's just like you're looking at it, you're saying like, does this have a good vibe for the white player or not? You know, which one is in a better position at this point? Anyway, then you train it to agree with the human judgment on average. You train this neural network, and then once you have a reward model vibe check, you run reinforcement learning with respect to it, learning how to play moves that lead to a good vibes. Clearly, this would not have led anywhere too interesting in Go. There are two fundamental separate reasons for this. Number one, the vibes could be misleading. In other words, the person is wrong. And number two, you'd find out that your reinforcement learning optimization goes off rails as it quickly discovers board states that are adversarial examples to the reward model. Remember that the reward model is a massive neural net with billions of parameters imitating the vibe. There are board states that are, quote, out of distribution, or in other words, it's outside the training data, which are not actually good states, yet by chance they could get a very high reward from the RM. For the exact same reason, reasons, sometimes I'm a bit surprised that RLHF works for LLMs at all. The reinforcement model we train for large language models is just a vibe check in the exact same way. In other words, do humans prefer one thing or another? It gives high scores to the kind of assistant responses that human raters statistically seem to like. It's not the, quote, actual objective of correctly solving problems. It's a proxy objective of what looks good to humans. And this is exactly the kind of problems that we have sometimes. It aims to please to such an extent that sometimes it hallucinates or just does other crazy things in order to try to please us human beings, because that's its primary reinforcement mechanism. Second, and this is something I didn't really know, you can't even run RLHF for too long because your model quickly learns to respond in ways that game the reward model. These predictions can look really weird, e.g. you'll see that your LLM assistant starts to respond with something nonsensical like the to many prompts, which looks ridiculous to you, but then you look at the RM vibe check and you see that for some reason the RM thinks these look excellent. Your LLM found an adversarial example. It's out of domain with respect to the reinforcement model's training data in an undefined territory. Yes, you can mitigate this by repeatedly adding these specific examples into the training set, but you'll find other adversarial examples next time around. For this reason, you can't even run RLHF for too many steps of optimization. You do a few hundred/thousand steps and then you have to call it because your optimization will start to game the RM. This is not RL like AlphaGo was. And yet, RLHF is a net helpful step of building an LLM assistant. I think there's a few subtle reasons, but my favorite one to point out is through it, the LLM assistant benefits from the generator discriminator gap. That is, for many problem types, it is a significantly easier task for a human labeler to select the best of a few candidate answers instead of writing the ideal answer from scratch, and that makes perfect sense. A good example is a prompt like generate a poem about paperclips or something like that. An average human labeler will struggle to write a good poem from scratch as an SFT example, but they could select a good-looking poem given a few candidates. So RLHF is a kind of way to benefit from this gap of, quote, easiness of human supervision. There's a few other reasons, e.g. RLHF is also helpful in mitigating hallucinations, because if the RM is a strong enough model to catch the LLM making stuff up during training, it can learn to penalize this with a low reward, teaching the model an aversion to risking factual knowledge when it's not sure. But a satisfying treatment of hallucinations and their mitigation is a whole different post, so I digress. All this to say that RLHF is net useful, but it's not reinforcement learning. No production-grade actual reinforcement learning on an LLM has so far been convincingly achieved and demonstrated in an open domain at scale. And intuitively, this is because getting actual rewards, i.e. the equivalent of win the game, is really difficult in the open-ended problem-solving tasks. It's all fun and games in a closed game-like environment like Go, which makes sense, where the dynamics are constrained and the reward function is cheap to evaluate and impossible to game. But how do you give an objective reward for summarizing an article, or answering a slightly ambiguous question about some pip install issue, or telling a joke, or rewriting some Java code to Python? Going towards this is not in principle impossible, but it's also not trivial, and it requires some creative thinking. But whoever convincingly cracks this problem will be able to run actual RL, the kind of RL that led to AlphaGo beating humans in Go, except this LLM would have a real shot of beating humans in open domain problem solving. And this again is the post that Ashok responded to by saying it's game over when we actually figure it out. And now let's recall that Ashok is in charge of not just Tesla's AI, but their full self-driving and I believe also Optimus as well. Which brings us to a really interesting segment of the recent Lex Fridman podcast where he interviewed Elon Musk, and Elon said that reality scales like reality.
With Optimus, there might be hundreds of millions of Optimus robots, maybe billions, learning a tremendous amount from the real world. That's the biggest source of data, I think, ultimately, is sort of Optimus probably. Optimus is going to be the biggest source of data.
Because it's
reality scales. Reality scales to the scale of reality. It's actually humbling to see how little data humans have actually been able to accumulate. Really, if you say how many trillions of usable tokens have humans generated, where on a non-duplicative, like discounting spam and repetitive stuff, it's not a huge number. You run out pretty quickly.
So given that Ashok and originally Andrei Karpathy both worked on real-world AI as opposed to large language models, in other words, things where you have an object interacting with reality, like a vehicle or like an Optimus robot or something like that, what Elon is talking about here is that reality scales with reality. In other words, the feedback that you get from reality is much, much more dense than you can ever get from human beings or our writings, the trillions of tokens that we've actually generated in terms of writing. And that's what large language models have been pretty much restricted to. They're just trying to predict the next word that a human would have written. And then as the icing on the cake, we actually ask humans to evaluate the output. And that has some significant problems. Number one is speed. Number two is the fact that you can't do that reinforcement learning with human feedback too many epochs, is what Andre said. So you can't continue it forever because it eventually goes off the rails. So number three, as a consequence of this, reality is a much better feedback system than humans are. Or to add a footnote, a really, really good simulation of reality. In other words, something you can put on a GPU, but it has to be a really good simulation of reality. All right, with that said, let me read my response here. Interesting thread. What could a good reinforcement learning with human feedback look like? Likely it'll be without human in there, right? In other words, it'll be reinforcement learning without humans. The really intriguing aspect of this, to me, is the use of reality as the objective function for reinforcement. The downside, reality only scales with reality, with thanks to Elon for that one. In other words, it's tough to gather data rapidly and efficiently using that methodology. The upside, if you have enough, quote, reality data, you can do reinforcement learning very effectively. Simulation can help somewhat here, but we end up in the 80-20 situation. 80% of the way there was simulations, but the last 20% is really hard. And as I've been banging the drum on a lot, I keep saying 2024 is the year of embodied AI. What this all comes around to is that embodied AI in the form of robots, cars, or humanoid or whatever, has a massive leg up when it comes to potentially beating the RLH conundrum that Andre has laid out. I guess it's reinforcement learning through reality feedback, or RLRF instead. Tesla, via Full Self-Driving and Optimus's network, has a huge head start here. Other embodied AI companies like Figure, Sanctuary, Agility, 1X, etc. also have reality on their side, and NVIDIA's Isaac simulator to get the 80%, but they lack access to reality for the last 20%. As Ashok says, it's game over when we figure out how to do RLRF effectively, as that will allow full self-driving and humanoid bots and plenty of other things to learn how to interact with reality in ways that humans might not even have figured out yet, which leads to the potential for superhuman abilities. In short, as I keep saying, embodied AI has the best chance to level up AI to the next level, call it AGI if you wish, and to shock us with their abilities. LLMs, I believe, are hitting the quality asymptote, so further improvements will be painful. Embodied AI, on the other hand, is just getting started. So all of this just reinforces my contention that reality is the best form of feedback. Now, the problem with reality is it's very, very messy. As Elon says, it's very open-ended. There's no way to create the equivalent of the rules of Go or of chess or of checkers or whatever game you want to suggest. Those are very, very simple closed systems where it's easy to understand the rules, and it's also easy to understand who won or lost. When you get to reality, it's significantly different. Even taking something as, quote, simple as driving a car, there's the obvious win or loss of not hitting, another object, a person, a car, or something like that while you're driving. But there are more subtle ones too, like, is it comfortable for the people in the car? Do you get there in an efficient amount of time? I mean, we could go at 1 mile per hour across these roads and everything, and the car is going to get there very safely, I guess, unless somebody rear ends it, but it's going to be incredibly inconvenient to the human passengers and to everybody else on the road at the same time. So you have to optimize for a bunch of different things at the same time, and they're open-ended and they interact with each other. They're not orthogonal to each other. They actually are associated with each other, which makes just determining what the loss function of reality is, it makes it way, way harder than a game, which is why people haven't solved this yet. But Tesla's FSD and Optimus and the other humanoid robots that are working on this same space are working very hard to try to figure out what that reinforcement learning through reality feedback is going to look like. And if, and I think when they get this, I think they're getting close enough that with enough data, they will be able to actually do RLRF as opposed to RLHF. And when they get their embodied AI in the form of humanoid robots or cars or whatever, are going to take a massive leap in front of large language models. They're going to become significantly smarter than large language models. And my prediction is that large language models are going to get rolled into these things. Obviously, we're going to want to talk to our car and especially to our humanoid bots, but that those large language models will have a massive leg leg up on large language models that are just sitting on a server cloud somewhere. They will have access to experience that's much more like human experience, and therefore should blow through that quality asymptote and get to artificial general intelligence much more rapidly. So that's my case, but to close this down, I want to give a little bit of a counterexample here. This is Strawberry, or I Rule the World demo, who actually is following me now, which is very cool, who is potentially an agent, an actual GPT agent that's out there from OpenAI that is the result of Strawberry or Q Star, and I did another video on that. You can check it out up here or at the end of this video. But anyway, if Q Star or Strawberry is as good as people are saying it is, it might be actually making a pretty significant leap in the ability of these large language models to directly model reality and reason on it. So does this blow up my case and Andre's case? No, not at all, because embodied AI, something that will be able to get feedback directly from reality, won't have to deal with the asymptote that all of these language models will have to deal with, which is that language is just a, it's just a representation of reality. It's an abstraction that we use to talk to each other and to communicate, and it's very, very effective, but it is not reality. I can talk all day about this cup and describing it, something as simple as this, but simply, letting you pick it up and hold it and move it around and everything will give you a significantly better understanding of what that cup is than describing it for, 20 pages or something. Those two things are probably equivalent. If you remember the old adage, a picture is worth 1,000 words, that's kind of what we're looking at. Reality is worth thousands and thousands or maybe millions and millions of written tokens. So as I concluded here, embodied AI has the best chance to level up AI to the next level, AGI if you want, and to shock us with its abilities. All right, so that's what I've got for you all today. Definitely let me know in the comments what you think, whether you agree or disagree or have other information. I would love to know. And while you're down there, if you don't mind liking and subscribing, that really does help out the channel. So thank you so much for doing that. And in the meantime, I will see you in the next video. Bye-bye.